It reconnected. It might be working now. Okay, fine, whatever. So you kick 4 out, and then you have p to the negative 3. This is basic derivative, right? 4, negative 3, p to the negative 4, which is negative 12 over p to the 4. No need for quotient rule on something like this. Let's open the gates of hell, see what's cooking.
Quotient will work with it. It's a little slow.
Yeah, oh yeah, it works. You can come to RV through Holland Tunnel. that's the short answer to it. Right? All right. Now, this is where fun begins. What do we have in this monstrosity of the problem? Can you give me the features?
Product rule and quotient rule.
Excellent. I hope that you all see multiplication of two functions in the numerator. That's the product rule. At the same time, that is divided by x plus 1, which makes it a quotient rule, right? And now if you add another one over here and you put the nose and the eyes, and you get a snowman. I had to toss that in. So this is product rule within quotient. So which one is the main rule, the big rule for the problem? Quotient rule is the big, right? Quotient rule is the big one, and then the product rule is going to happen only when you get to take the derivative of the top. So this is where the product is going to kick in. You are doing the quotient rule because the entire problem is the quotient rule. And then the product will be done when we have to take the derivative of the numerator. And that only happens with that u prime. So now I am doing the quotient rule. Quotient rule clearly says copy denominator as is and then square it, and then copy denominator one more time. Times, take the derivative of the numerator. This is where product rule kicks in. I'm going to do that in red. Product rule says copy the first derivative of the second plus copy the second derivative of the first. Then you have minus, and you continue your quotient rule. Your quotient rule would be xe to the x times derivative of the denominator, which is 1. Woohoo. This is called mathematical gymnastics. It falls under that, look what I can do. And it's not that useful, but I can do it. I have to. So I'm going to kick e to the x from the red parenthesis. And if you notice, you have x plus 1 times x plus 1, which is squared, right? Minus x e to the x divided by x plus 1 squared. Now, I am going to put e to the x in front of the fraction. What I am left with on top is x squared plus 2x plus 1 when I FOIL, and then I have minus x divided by x plus 1 squared. Please never, ever, ever square and worry about the denominator. Just leave it. Just drag it along. So this is e to the x squared plus x plus 1 divided by x plus 1 squared. And right, this would be the answer. My MATLAB should be happy with this answer. So now I'm going to go one more time over the entire problem. If you missed writing anything, eventually I'll get there. So we have the product rule inside the quotient rule. So product rule inside the quotient rule, and quotient rule is the main, which means that the whole problem over here is the quotient rule formula, and then the product rule is used only when I have to take the derivative of the numerator, which is the product rule. The rest is all quotient. So the quotient formula was done as you have a v squared on the bottom, you have a v, you have a u prime, which was a product, and then you have your u, and then you have your v prime. After that is the algebra, right? What I did is I factored out e to the x. I factored out e to the x, which goes in front, and then that's this e to the x, and then you have another e to the x here, and you can factor that all out. So now that we have e to the x out, the rest is FOIL this and then subtract x. So here's the FOIL and subtract x. And then from there, just combine the like terms, 2x and negative x, to obtain this positive x here, and the problem is solved. And the problem is factored, problem is ready for you to say equal to 0 in chapter 4. Now, the reason why I said don't ever worry about the denominator, foiling it or whatever, is because once you in chapter 4 set is equal to 0, this 0 kills the denominator when you cross multiply, right? When you cross multiply, the denominator will multiply into the 0 and it'll just be gone. So it doesn't matter what you have there. You don't have to worry about it. Good. One more problem. Then we're going to take a short break. When we come back, we'll do the trigonometric derivatives. And then we go. So this is problem 54. Find the derivative. They are using z, but I noticed that a lot of you are not crossing z's. Then they look like 2's. And then 2 or 3 steps down the problem, you make catastrophic mistakes. Now, as instructor right now, instead of fixing that problem and telling you cross your z's, I change z to x, which I shouldn't be doing, because once you reach Calc 3 and you have throw-dimensional calculus, which is done on x, y, and z axis, can I swap your z? I can't, right? So I shouldn't be swapping the z now. Unfortunately, I am. If you are already crossing your z's, or you want to practice crossing your z's because you need that skill to survive later on, to distinguish between a quick 2 and a quick z, like how do you know which one is which? If you write both of them the same way, once you are stressed and you're doing it fast, right? Cross your z's. Then use your z's, right? We have x squared or z squared, whatever you want to use, over, so x squared plus 1 over x times e to the x, or times e to the z if you're using z's. Which rule is the main rule for the problem? Product. Thank you. And you will do the quotient when you get to the part differentiate first, which is at the end of the problem. That's when the quotient kicks in. So you're doing the product rule, and then you get to differentiate at the end as a quotient. Very good. So product rule. Copy the first, which is x squared plus 1 over x, times derivative of the second, well, it stays the same, plus copy the second, which is e to the x, times derivative of the first. This is where the quotient rule kicks in. So we have x squared, then I have x times the derivative of the top is 2x, minus the top copied, which is x squared plus 1, times the derivative of the denominator, which is 1. All right, so now clean this up as much as possible. We can kick e to the x out, leave x squared plus 1 over x as the first term, plus, now this becomes 2x squared minus x squared minus 1 divided by x squared, which is e to the x squared plus 1 over x, plus x squared minus 1 over x squared. Technically, you could leave it, but don't. Common denominator of x. So we are going to hit the first fraction with the multiply by x, e to the x. Common denominator is x squared. We have x cubed plus x squared minus 1. And then we just put it in a descending order. So x cubed plus x squared plus x minus 1 divided by x squared. And this should be the answer. Yes, thank you. Perfect.
For the, what did you do with the quotient rule?
I did the quotient rule. We have a product rule over here. So this is my f. This is my g. The product rule is fg prime plus gf prime. Since f is this, here is the f prime, because you have your, let's actually write them all out. This is your f, this is your g prime, this is your g, and the whole thing over here is your f prime, because that was the derivative and you had the quotient there.
So
as I said.
The only time you do the quotient rule?
Yes, because it's the quotient within the product. Product is the boss equation, quotient is inside. Previous problem, quotient was the boss, product was inside. So the form of the question will dictate which one you get to do. And I really hope, guys, that you will practice this a lot over the break. Well, I can assure that, putting a lot of that on the quizzes, because chain rule is coming up. And then it will be basic derivatives, product rule, quotient rule, chain rule, and when you mush them all together, you're going to have the product rule within the chain, chain within the quotient, quotient within a product, which is all the chain, right? And it's going to get really, really not fun. It's going to be annoying. It's not hard, all right? It's not hard. But there's a difference between annoying and hard. This is not hard when you know the formula. It's just annoying because there's a lot of writing and a lot of algebra to simplify it to the point when you can solve equations quickly, right? So, you know, we'll work on it. So you have plenty of examples to work off of. We're going to stop here and then resume in about 5 minutes or so with trigonometric derivatives, where we're going to learn those 6 derivatives, take a look at some properties. It's a very quick and short lecture, and that's it. So 5 minutes.